So we are going to be graphing secant and cosecant today. Tell me, what does cosecant have to do with sine? It is the reciprocal, right? It is the reciprocal. So what we're going to do is we're going to just plot sine, and then we're going to reciprocate the values to see what cosecant looks like. So I have a column here for sine. See, the sine values start at 0, 1, 0, negative 1, 0. I'm going to go down here and I'm going to plot sine, but I'm going to do it lightly and dash it because it's not really the graph we're doing right now. The sine starts at 0, was the 1. And hopefully we are somewhat familiar by now with the shape of sine. Fingers crossed. Your sine graph doesn't have to be absolutely perfect because it's not really a graph for graphing. It's just going to aid us in finding cosecant. So now I'm going to go and I'm going to reciprocate the values. So 0. What is the reciprocal of 0? Undefined. And the reciprocal of 1 is 1. Reciprocal of 0, undefined. The reciprocal of negative 1 is negative 1. And the reciprocal of 0 is undefined. So we have 3 undefined values, and we have to graph those somehow. Anytime you have an undefined value, it's going to be a vertical asymptote, and it's going to be, since it's vertical, it's going to be at x equals that value. This one, it's going to be the x value, so it's going to be at x equals pi. And then this one here is going to be at x equals 2 pi. Those are going to be the asymptotes. And the asymptotes are not really part of the graph either. They're just helping us graph it. So they're going to be dashed. So at 0 and at pi and at 2 pi, I'm going to put a vertical dashed line and know that that's my asymptote. And because these graphs are periodic, they repeat, evenly spaced, so I can put in all the other asymptotes. Basically, there's an asymptote every place. Oh, that's awful, but every place where sine was 0. Every place where sine was 0, there's now an asymptote. Now, in our table where sine was 1, and then we reciprocate that, cosecant is now 1. So at pi over 2, 1, that point is still the same. And at 3 pi over 2, negative 1, that one's still the same because we reciprocate negative 1, it's still negative 1. So that point's still the same. And then we don't have to do this every time, but we're going to do it just this once to find out where more points are. I'm going to think about the unit circle, and I'm thinking about sine. And sine at pi over 6, which is 30 degrees, is what value? Half. So sine at pi over 6 is a half. So if I found pi over 6, that's going to be really close to pi. The green part, my green dashed line, is a half. What would be cosecant?
6. 2.
2. It would be the reciprocal of a half. So about there, it's going to be at pi over 6, about where pi over 6 would be. That's going to be 2 for our new cosecant. But that's not the only place where sine is a half. Sine is also a half in this quadrant. at 5 pi over 6. So approximately 5 pi over 6 is almost to pi. At 5 pi over 6, sine's a half, so cosecant is 2. And then in the third quadrant, at 7 pi over 6, which is just past pi, what's sine? Negative a half. So sine's negative a half about here. That means that cosecant is negative 2 there. And then all the way almost to 2 pi at 11 pi over 6, sine is negative a half. So cosecant would be negative 2. And then what happens as the graph gets closer to the asymptotes? Like as it approaches those asymptotes, what happens to graphs normally? Dominic? Yeah, it gets like, it goes really like vertical, and it gets closer and closer and closer to the asymptote. So I'm just going to approximate that from this point here. I'm just going to get closer to the asymptotes on either side. And from this one, it's going to go more and more negative, just get closer to the asymptotes. And that's what one cycle of cosecant looks like. One full period of cosecant. And remember, these are periodic, so they repeat over and over again. So anytime that I have the sine with a maximum point, that top point, that's going to be the minimum of the cosecant. And you don't really have to find that half, that 2 dot in there. That was just for me to help you see why it looks the way it does, but I don't ever find these extra dots. Anytime where the sine is at a minimum vertex, then this would be a maximum for cosecant. And you just complete that pattern. I am going to draw a bad cosecant graph so you can see what not to do, because I see it. I'm just going to draw it on top of this one here. Cosecant does not do this. Okay? It gets closer and closer and closer to the asymptotes. It doesn't go to the asymptotes and come back. Okay? So just be careful. It just gets closer to the asymptotes, and the more you zoom out, it just looks like it's part of the asymptotes. It doesn't actually ever touch them, but please don't curve it in. Yeah. Okay. Now, at underneath the chart, it asks for the asymptotes. We're going to list all the asymptotes that ever were on that graph, ever. How many asymptotes are on that graph? Infinitely many? Sounds like a lot of writing. So we're going to shorten that a little bit. The asymptotes are equations at x equals some number. And we're going to always begin with the first non-negative asymptote. So I look at my graph, and x equals what value is our first non-negative asymptote? First as in lowest amount. 0 is our first one. So I would put a 0 there, but if it's 0, it doesn't really show up. So there should be a 0 there, but I'm not writing it. I'll just put it underneath so you can see it's supposed to be there. And then after that, how far apart are these asymptotes spaced? At every pi after that, right? So there's pi apart. So what we're going to do is we're going to take that 0 and we're going to add on pi. But how many pi's do I add on to get to infinity? I don't know. So it's a variable. We're going to call it k. Except k has to be more specified. So I'm going to actually have my asymptotes as x equals k pi, and then I'm going to have to say something about k. But I got it from 0 plus k pi. I wanted to show that because it doesn't always start at 0. Sometimes it'll start somewhere else. Okay. We have to say something about k, because k says, you know, the number of pies to get any of these. So if k was 1, that would be 1 pi, and we have an asymptote there. If k was 2, there would be an asymptote at 2 pi. If k was negative 3, there would be an asymptote at negative 3 pi. If k was 100, there would be an asymptote at 100 pi. If k was a half, is there an asymptote at half pi? No, so we have to specify that k is only what kind of numbers? Well, the pi part, it comes from that, but the k itself is only what kind of numbers? Whole numbers does not include negatives. Do you know what it's called when it's the whole numbers but negatives and positives? Yeah, good job. Integers. So you just say where k is an integer. And yes, you have to say that, so suck it up and do it. Okay. And when you're ready, we're going to fill out the next one, which is secant, which is cosine. So, oh, and I copy and pasted wrong, so mine should say cosine here and should say secant. Whoops. My bad. It's right on your paper. I just did it wrong on this one. Okay. Cosine starts where? 1. And then we have to reciprocate it for secant. So 1, and then reciprocal of 0 is undefined. And we have negative 1, and we have undefined, and we have 1. So those are our secant points. Every place that I see an undefined, what is that going to be on the graph? Asymptote, right. So I'll go ahead and draw my asymptotes at pi over 2 and at 3 pi over 2. And are those the only asymptotes that I'll draw? Nope. Because it's periodic, it will repeat. How far apart are they? Pi. This is the parent function. There's nothing fancy right now about it. They're all spaced. I'm going to draw my cosine graph in there and just lightly dash it so I can see where it was. Okay, and then in our table at 0 we have 1, right? Our table, I can't see it. You guys have it. 0 we have 1. At pi we have negative 1. And at 2 pi we have 1. Right? And then this graph is going to look very similar to cosecant. Because remember, sine and cosine are almost the same graphs. They're just shifted 90 degrees from each other. So this is going to be the same way. It's just going to be same exact look, just shifted 90 degrees from cosecant. So the graph itself has to go away from its reciprocal. So it has to go away from the cosine. It gets closer to the asymptotes. Anytime cosine is a maximum, then secant is a minimum, or vice versa. Okay, once you have that graph, then we got to figure out our asymptotes. Our asymptotes, we're going to pick the first, or our lowest one that is non-negative. So what's our first asymptote that's not negative? Okay, so I'm going to start with x equals pi over 2. So I'm going to pick that first one. And then I'm going to be adding on multiples of what? Pi. So k pi, where k is an integer. K could be a half, could be a tenth, yes.
Can you do times K with K is every odd integer? Would that work?
Hold on a second. Do what times K?
Where is every odd integer? So it'd be 5, 3, 9, 11.
Would that give us every single one? If I start at pi over 2 and I add,
1, 2, 1.5, 3, 1.5, 5, 5.
I'm sorry.
You know what I mean?
No. So if I start at pi over 2, and what are you saying that I add on?
It'd be every odd, so it'd be 1. So you multiply that by 1, so 1 times 1/2 would be, or, you know, pi over 2. And then 3 pi over 2 is 1/2, 1.5, and
So how would you phrase this differently?
1/2 K.
So you do pi over, okay, so you do pi over 2 plus K over 2 half K pi, where K is an odd integer, is that what you're saying?
No, I just did 1/2 K, or pi over 2 times K. That was it.
Oh, you did pi over 2 multiplied by
Just K.
K,
So K is an odd integer.
maybe. We just never write it that way.
I just didn't want to write plus.
I don't know, but you made it way more confusing for me, so. Tell you what though, all of the other graphs that we're gonna do have these, asymptotes. When we do tangent, they have asymptotes. When we do cotangent, they have asymptotes. And all of them follow the same pattern of how we write our asymptotes. If you wanna write it a different way and you're creative and that's fine, and if it works, great. But I'm gonna keep it consistent, because I don't like to have to memorize more than one thing, even if it's extra writing. Yes?
So when we're doing it where there's like actually like an equation there, do we,
Like this one?
yeah, like,
Yes.
do we put, like do the reciprocal first?
That's what I'm gonna do. Yeah. It could be either. But I'm going to think of sine, because cosecant is sine. So I'm going to think of sine and say at 0, sine is 0. At pi over 2, sine is 1. Right? I'm going to think about that. And then when I actually fill out the chart, I'm going to use 0. Oh, no, not 0. I'm going to use undefined. And I'm going to use 1, undefined, -1, and undefined. And then I'm going to apply my transformations to cosecant. Okay? But you can do it in the other order. I know some teachers teach it in the other order. So this has a vertical stretch factor of 3, so we're going to multiply our verticals by 3, and then after that we're going to add 2 vertically. So when you go to multiply, so let's imagine a vertical asymptote, okay? And I'm going to take that vertical asymptote and I'm going to stretch it vertically. I don't think I can do it on here, but I'm going to stretch it vertically. Oh, I can. Is the asymptote at a different location if I stretch it or shrink it vertically? No, it's just, and it's not getting longer because it has arrows. That means it goes on forever, so it's still going on forever. So if you multiply by 3, it doesn't change the undefined. If I add 2 and I take this asymptote and I move it up 2 places, that was really wiggly. If I move it straight up 2 places, does it change my asymptote? It's still going on forever vertically, so this asymptote stays, the asymptote at undefined, like you don't have to change anything for those. Those are still undefined. Will anything to the x value change the asymptotes? Yes. Just nothing to the y's. So we just have to multiply by 3 and then add 2 to the values that are actually there. And we will remember always graph the outermost x and y. So at 0, undefined, What was next? Pi was undefined. My chart in front of me. At pi over 2, it was 5. And at 3 pi over 2, it was -1. So I got it on my chart. The sine function that would have been there had a midline at 2, at 0, and then it was moved up to 2. So the midline for the sine function that was there, wait, what's it moved up?
2.
Yeah, that's right. It just didn't look right for a second. So the sine function that was there would be here. So you can put it in if you need it. I know some people like to put it in. Some people don't care. But you can put the sine function in to help you. It's just not part of the graph, so it's not necessary. I'll finish my asymptotes. And finish my dots. And how can you describe which way these open? Do they cross, when they open, they go away from each other? Like when they open in up or down, they're going away from each other. So if it's a minimum point, it's got to open down. If it's a maximum point from the sine function, then it's going to open up. From the sine function, if it's the bottom point, then the cosecant is going to open down. That's why I was like, that wasn't fast enough. So they're not going to cross over the sine function ever, going away from the sine function. And when you're ready to go ahead and turn it over, so you go to the That's why some people like to have the sine function in there, so they make sure they don't cross it. Oh wait, we forgot something. Wait. Oh, my asymptote, sorry. It's like not showing on the screen and then I forget to do it. X equals, what's our first non-negative? 0, so I'm not going to write it. We're going to add on K multiplied by what's the difference between all of the asymptotes? Pi. Where K is an integer. Alright. So next one says secant. I know that is cosine. So I'll think about my cosine points. My cosine points start at 1. But in my table, I fill out my secant points.
Are you doing the opposite, the reciprocal of the x values that are in the chart, or the cosine, or the cosine?
It is the reciprocal of cosine. So the x values are the angles. So if we talk about cosine at pi over 2, that's 0. And if we talk about secant at pi over 2, it's the x over r, or r over x that get flipped. It's the 0. All right, what transformations do we have? We've got a -2 in front. What does that tell me to do in my table? It's going to be the y's. We've got a reflect in the x-axis and a vertical stretch of 2. We're going to multiply -2 on the y side. So how does multiplying undefined by -2 change it? Doesn't. It's still undefined. Then what does the minus pi tell us to do? We're going to add pi to the x values. So that's a horizontal translation. So that changes the x values. So what that does, remember we only graph like the outermost stuff. When I changed my x values, I took that asymptote that was at pi over 2 and I moved it over to 3 pi over 2. So we have asymptotes in different places now. Since the asymptotes are affected by x transformations, the asymptotes are different. So we got an asymptote at 3 pi over 2 and at 5 pi over 2. We have at pi negative 2, at 2 pi 2, and then at 3 pi negative 2. You could, if you need to, fill in your cosine function so that you can tell where the secant function is going to go. I'm going to continue my pattern with my asymptotes. Remember, the secant and cosecant go away from cosine and sine. So when you go to draw them in, they go away from each other. So if I can see where cosine was, I can see this was a minimum in cosine, so now it is a maximum going away from that cosine. This was a maximum in cosine, now it's in secant, a minimum. Look at the asymptotes, I'll fill those in a moment. I remember it this time. What is the first not negative asymptote? Pi over 2. And then what are we adding on? How much are we adding on? Pi, so k pi. Where k is an integer. That's unfortunately kind of messy. All right, last one. So I see secant. What should I think of first? Cosine. So 1, 0, negative 1, 0, 1. So secant 1, undefined, negative 1, undefined. We're going to figure out transformations. Do we have any transformations? What do we got?
What make it happen?
Oh, yeah. Yeah, Avery, what were you saying? Because it's what you're saying too, but you just didn't tell me the information. What were you
We
saying?
just have to take the half out.
We have to factor out the half first, right? We're going to factor out that half because it's got to be in front of those parentheses after the secant. So we'll have y equals secant, then half, then x plus 2 pi. We always want to do multiplication before adding or subtracting. So multiplying, what does that 1/2 do? multiplies by 2 on the x side. Is that going to change my asymptotes? If it's on the x side, it will. And then what does the Wu Yang, what happens next? Left 2 pi, so I'm going to subtract 2 pi here. So we're going to graph the outside stuff, and you can see that our undefineds are at negative pi and at pi. So those are going to be my asymptotes at negative pi and pi. I'm going to go ahead and do those asymptotes, negative pi and pi. And then I look at my graph and I'm like, how far apart are those? They're 4 blocks, but 2 pi, right? So you could think 4 blocks, you could think, I am going to need to know that it is 2 pi when I write my asymptotes. What else do we have? So negative 2 pi is 1. 0 was negative 1. And that, when it was cosine, would look like this. I went a little far on that side. Okay, remember that it goes away from the cosine, goes away. So if this is a maximum, then we've got a minimum. Almost done. Just got to fill out our information below. The period, 1 cycle. It's going to be the same way it was with with a cosine and sine. The period is normally 2 pi, but we did change it when we multiplied our x's by what number? 2. So I'm going to multiply my period by 2. Also, how long is 1 cycle? 4 pi. And when you look at the graph, it's the horizontal distance for 1 up and 1 down combined, because that's 1 full cycle, 4 pi long. Phase shift is left or right. Where'd it go? Left 2 pi. Vertical shift, up or down? None. Domain and range I'm going to come back to in just one moment. Let's do our asymptotes first. So we start with our first non-negative asymptote. That's at pi. And then how much are we adding each time? 2 pi, so we'll say 2k pi or 2 pi k. It doesn't really matter what order you write them in. Where k is an integer.
How's it 2 and not 4?
4 is the whole period, but within the whole cycle, there's an asymptote right in the middle of it. Like here's 1 whole cycle. The asymptotes are 2 pi part. Period is 1. Do you understand what I'm saying? Yeah. Okay, so from starting from that one, how far do I travel before I hit another asymptote? From pi to, yeah. Okay, the domain is left to right. Is it all real numbers left to right? No, because what happens when you get to an asymptote? Undefined. There is nothing in the domain. There's no x's there. So you have to describe that this is going all the way from negative infinity all the way to positive infinity, but skipping over every single asymptote. So if you found your asymptotes already, it's really easy to write the domain. We just say that x, try that again, x does not equal pi plus 2k pi, where k is an integer. So you're just basically saying the domain and range, the domain and asymptotes are the same. It's just domain doesn't equal it. asymptotes, that's what they equal. So you cannot write the domain in, what's that form? Interval notation. But we are going to write our range in interval notation. So our range goes from low to high. What's the lowest point that it goes? Negative infinity. And does it continuously go all the way to the top? No. Is there a stopping point? Yes. We're going from negative infinity to what number? Negative 1. And then what happens? It skips to 1 and goes to positive infinity. So we're going to have a union of two pieces for the range. We're going to have negative infinity to negative 1, bracket, union, bracket, 1 to positive infinity. So it's just skipping over in between negative 1 to 1. Easy stuff? Should be. Excellent. So I have a worksheet. I'll hand that out, and then you guys can spend the rest of your time on your quiz project if you need any extra time with that.